students, our new topic is law of conservation of energy. Okay, you have heard with me that the example that I have given you about the pot that is over the wall, like on the wall it is situated and from there it is fallen. So I have told you that there in that case the potential energy that is gained by that pot is get transformed into the kinetic energy. That is why it is moving. So what is law of conservation? Conservation means बचा के रखना, not to get change. Okay, so what we are doing here, we are conserving energy. We are actually conserving, yeah. How? So here is the theory about it, that according to this law, when the energy changes from one form to another, so the total energy remains constant. It will neither be created nor be destroyed. This is the basic rule of it, that the energy cannot be created nor be destroyed. It cannot be created nor be destroyed. Okay, we cannot even create energy by our own and we cannot even destroy it by our own. It is not in our hand. But what happened here, it just get transformed. It get transformed from one form of energy to another. Okay, so this is the main theory that is working behind the principle of law of conservation of energy, that total energy will always remain constant for a thing. Like, you know, the fallen of the pot, that now no potential energy is there because it is throwing out from the height and now it is moving toward the ground. So what we will say that this potential energy is get converted into the kinetic energy. So one form to another form. So here we haven't created it. Like earlier also, we just put that pot on the top of the wall. Okay, so from there what we have done, it is actually having a mass. So that is also a kind of sort of thing that a body is consisting it in self. So here we have provided our muscles mechanical energy to put that pot to the height. Here also we have used different energy to provide different energy, right? And that now when fallen off, it get converted into another form of energy. Okay, so this is how total energy will always remain constant, and when energy changes from one form to another, it will never get it will get transformed, but we cannot say it is get destroyed. Okay, it is not getting destroyed. Here there is no loss or gain of energy. It was earlier the same and after the same. Okay, total part is just get converted into another way. Okay, so this is what law of conservation of energy, and there are various examples of transformation of energy here. Let me discuss it with you. Like I have told you, energy cannot be created nor be destroyed. It just transformed from one form to another. So transferring means, I am telling you, like the potential here in the example previous, potential was transforming itself into the kinetic one, right? So it is transforming from this part to this part. Even there would be the example like kinetic could also be converted into potential energy. Okay, so here are various ways. So the change of energy from one form to another form is the transformation of energy. Okay, like the pot earlier was on the wall and then it is fallen. So potential get converted into kinetic, that is why it is fallen down. Okay, there are more example like this. The ball here is at the rest position, and when we uplift it like this, we are throwing it in upward direction. Here again, this is gaining, it is converting, like here in this example, as you can see, kinetic energy is getting converted into potential one. Okay, because here the ball is at the kinetic motion and that kinetic get converted into the potential when this ball is at the height, topmost height. ऐसा तो नहीं होगा ये ball infinitely आगे चलती जाएगी, not possible, but this will certainly get some height and after that it has to eventually get down. Fine. So that height now is again a potential part because it has contained certain height. Now it is again transforming itself into the kinetic from the height to the ground again. Okay, so this is how the transformation of the energy is done. So here we are having the list of examples of different energy transformations. That the electric motor, you have heard about it, is the electrical energy in that is get transformed into the mechanical one. Okay, we are plugging it and providing electricity and that keeps rotating the other things like mixture juicer, your fan, your cooler, your washing machine, all works on this principle. Okay, electrical generator, what is it doing? It is changing the mechanical energy into the electrical energy. How? When we are providing any external force to it, it get converted into electrical one. Okay, generator part you will see that these two theories in a very elaborated manner in class 10th. Okay, but that you need to know that here the mechanical part that we are actually applying any physical force there. I have told you about mechanical word. Okay, so physical force, like I have seen certain examples on like some auto drivers also. They tie the turbine with the rope and they pull it like this, and if they are pulling it like this, they are providing the mechanical thing and their the automobile's generator there gets started and that providing them electricity and that electricity is used to run the auto. Okay, so that is how it works. Electric iron again is the example. Here you are plugging it and that electricity get transformed into the heat part. Okay, radio, electrical energy into sound energy. When you are plugging it, electrical, even not the plug radios are available. In earlier time you were having, like in the time of the grandfather or grandmother used to speak about it, so they are having these cell radios. So cell is a sort of energy only. Okay, electrical energy it is providing. Even electricity is also of two kind of electricities. That one we are using right now in through the plugs and all, and the another one through the batteries. So earlier time we were using batteries to generate the different appliances like radio, and they again get convert the electrical energy into the sound energy. So this is how the transformation part is done here. And see, law of conservation of energy is very important topic. It always kept asked in the examination, so thoroughly keep going with this part and see different examples around you. So for conservation of energy, let me discuss some more example with you. Here we are having the falling brick examples that is given in your books also. That is why I am discussing it here, and with a great diagrams. You will going to learn it very quickly now. Okay, so what is it? See, a brick is here. Okay, that brick is at certain height. Okay, and earlier time also I have told you that potential and kinetic energy together makes mechanical energy. So mechanical is the thing that happens with the physical body, any physical state body that is having certain motion or any kind of change. Okay, but it should be implicable with the physical state body only. So that is why it is named as mechanical. So here you can see that the brick is a physical body. Okay, and that body is now moving here at the ground part. So we can say that it is doing a mechanical work. Now this mechanical work is having two things, potential and kinetic. But when this brick is at certain height point, it is not moving. Just suppose for a minute instant, limitized of the second, if we fraction the second into the million part and for just a while, it is being taken here, and that brick is now having just a potential, not a kinetic one, because this is not moving right now. So we can say potential is 30. Let's suppose we are imagining that this is the potential energy, that is 30 joules here, and kinetic part is not here. So it is kept as 0, and total energy, that is mechanical energy, it is here, whatever it is written here, TE, that means mechanical energy. Okay students, so 30 plus 0 will gives you 30 again. So total energy is 30, and here the potential is 30 but kinetic is 0. What we are going to see here, now see the next part. When the brick goes down from here to here, like now it is in motion and it is dropping down, so it is moving from its position, and now here the potential will reduce because the height get reduced, so the value of potential energy will also get reduced. It is 20, and now the kinetic, because it has gained certain motion value now, so 10 is the kinetic energy, and sum of it again will be 30. Yeah, right? Okay, now it is again going down further. Now the potential height is get reduced very much, 12, and kinetic, now it is gaining more speed. Why kinetic is gaining speed? Yes, any one of you can suggest that, because here the value of gravity is the part of acceleration. What is gravity? You have heard about it in the chapter gravitation. Those students who have learned that chapter very well get to know that this is what? This is acceleration. So means this brick is accelerated as if it is coming near to the ground. जैसे जैसे ये ground के पास आती जाएगा, वैसे वैसे acceleration value increase होती जाएगी, right? That is why here the speed of the motion of the brick will also get increased. So 18 is the kinetic part, but the sum of these two will always get remain same, that is 30. Okay, and now it hits the ground. While it is hitting the ground, just a second before that, what we can see, we will see that potential is now become 0 totally, because no height is here. 0 height means 0 potential, and kinetic now will be at its highest value. Okay, that is 30. So with this table, students, you get to know that in earlier part the 30 was the potential, but in the last part the 30 was the kinetic. But the total energy, that is the mechanical energy, was remained same in all the duration, that is 30. Okay, that shows us the law of conservation of energy, that the total energy will remain the same though the position of the brick is going to change and the speed of the brick is going to change. So this was the example 1 that we have discussed over the law of conservation of energy. And now let me discuss the second example for you, that is the pendulum example. Here also you know that is the bob. Okay, so that bob part of the pendulum, because it is at the center part earlier. Okay, now you know that the bob of the pendulum get moved from here to here. Okay, so now you can say from the center it is moving here and again to here and again here, then again here. So students, as you can see, this is the highest point till that it can move, and from here to here, now again it is coming to the mean position. Now again on the different part of it, on the opposite part of it, it is again going to the extreme point. Now again coming to the back to the mean position. So we can say that it is the mean position or the center position, and these are the extreme positions. So at extreme position, that means this height is totally, that is being gained by this pendulum. When this is the height, that means here the potential energy is the highest and kinetic energy will be 0 at this position. Why? Because after that it is not going to move further in this direction, it is going towards the back direction again. So we can say that potential energy is the highest one here and the kinetic one will be 0. Now after that it is again regaining its position and moving back to the direction. So kinetic will going to increase here to here. Now it is at the mean position. Here at this position potential will be 0 and kinetic will be maximum. Why? Because now it is nearest to the ground and that makes it potential energy to the 0 value, and kinetic because at this position also it is not getting rest because of the inertia that has been gained by the ball here, that keeps it making going on like this. Okay. So I have used this example to represent the pendulum, and that pendulum it is working on law of conservation of energy also. So see, this is how this going: potential and kinetic 0, potential 0, kinetic high, and again at this position potential high, kinetic 0, and back to the position. So students, this is all about this chapter, work, power, energy and power. I hope you understand it very well. So revise it well and do all question answers thoroughly and keep going. Thank you.